Okay, folks, today we're going to talk about arithmetic sequences. If you guys have been working on your online homework, you would probably have seen this. Let's see here. Okay, so the idea with arithmetic sequences is that in an arithmetic sequence, the difference between each pair of consecutive terms is the same. This difference is called the common difference. Each term is found by adding the common difference to the previous term. So an example here, 5, 10, 15, 20, our common difference is 5. So we're adding 5 to each term. Okay, so this is our first term, second term, third term, fourth term. 5 plus 5 gets you to 10, plus 5 is 15, plus 5 is 20, plus 5 would be 25. That would be the fifth term in that sequence. Okay? So if we kind of move down to the center right here, and we're talking about writing the terms of an arithmetic sequence, right? A sequence is an ordered list of numbers. Each number in a sequence is called a term. Each term, an, has a specific position, n, in the sequence. So again, first position, second, third, fourth, fifth, and so on to the nth position. So the idea with 1 and 2 in our examples right here is we are going to be writing the next 3 terms of the arithmetic sequence. So position 1, term is negative 12. Position 2, your term is 0. Position 3, 12. Position 4, 24. So we can see, if we just kind of like read the pattern here, that our common difference is going to be 12. Negative 12 plus 12 is 0. Plus 12 is 12. Plus 12 is 24. Plus 12 would be 36 for the fifth term in your sequence. Sixth term is going to be 48 as we add 12. Seventh term is going to be 60 as you add 12. Okay? Now we can extrapolate that out even more, right? We can find the 8th term at 72, the 9th term at 84, and so on, right? And we can also go backwards to term 0, or sorry, position 0, when we, extend that the other way to negative 24, and position negative 1 to negative 36, okay? So you can go up and down in your arithmetic sequence, okay? But that first term is always called A1. All right. All right, so we get to our second example right here. Our first term is 0.2. Second term is 0.6. Third is 1. Fourth is 1.4. We can see that our common difference each time, it should be a 0.6. All right, so weird looking 6. We can see our common difference is 0.4 each time that we're adding. Okay? And so I take 1.4 and I add 0.4, I get to 1.8 for the fifth term. Our sixth term is going to be 2.2, and our seventh term, as I add 0.4 to that, is going to be 2.6. And again, I could continue this out. Our eighth term would be 3, our ninth term would be 3.4. And I could also continue with the other way, with our 0th term being negative 0.2, our negative 1th term, being, let's see, negative 0.6, and so on, okay? Again, guys, if you need to rewind this to get something that you missed, or if you need to pause it to catch up, feel free to just ask either the sub or the set to take care of that for you. I'm going to take a quick slurp of my tea right now. All right. Second page right here, folks. To graph a sequence, right, we can actually look at this in terms of x's and y's, right? So our term's position is going to be our x value, and then our terms are going to be our y values, right? So if I have my first position, the term is 24, second is 18, third is 12, and our fourth position is 6, right? We're not adding each time, right, for this one. Instead, we are subtracting 6 as our common difference each time, okay? So it's going down rather than up, so that's a negative graph. And so for my scale on my x-axis, I'm going to put 1, 2, 3, 4. And for my scale on my y-axis, I'm actually going to go up by 2s rather than by 1s. So 2, 4, 6, 8, 12, 14, and so on. I'm not going to, did I screw up here? 2, 4, 6, 8, 10, 12, 14, 16, sorry guys, 18, 20, 22, and 24. Okay, so the first point is going to be 1, 24, so I go over to the right one, I go up to 24. My second is 218, so that's going to be right there. Second is 312, so it's going to be right there. And my fourth is right there at 6. So before we even graph it, okay, 10, 12, yeah. Before we even graph it, we're going to see that we have, oh gosh, did I screw up here? Let's see what I did. See, 1, 24, 2, 18, oh, down by 3, down by 3, down by 3. They're just like, actually, I think I just screwed my line up right there. Okay. So we can see that this arithmetic sequence is going to form a line. Okay, so this is actually really a linear equation. Okay, forms a line! Exclamation point. So yeah, arithmetic sequences are linear functions. Okay. So number 2, does the graph represent an arithmetic sequence? Well, let's take a look. If I draw a line right here, I can see that it very clearly forms a straight line. Well, all lines are straight. We're sure. Come on, get it together. So let's put these, our terms and our positions in a table right here. Okay, so those are our positions, right? And our terms are going to be 1.5, 3, 4.5. And then 6 for our fourth one right there. And then if we're looking at our pattern right here, we can see that as our x values increase by 1, our y values increase by 1.5. So we have a constant rate of change for this, right? Goes up by 1s as well, with a common difference of 1.5. Okay. And since the common difference, right, it's common each time you increase your position, right, we can say that yes, this is an arithmetic sequence because your term and position have a constant rate of change. Right? Constant rate of change is basically the same thing as that common difference right there that we talked about. We can get that on there. Sorry about that. We'll leave that up for a few seconds, just to make sure everybody can get that. Again, if you need to rewind or pause, please do so. Okay. Now, this is where the real heavy math comes in, right? This formula, real small right here, so let me rewrite it, okay? AN is equal to the first term in your sequence plus n, which is the term you're looking for, minus 1 times your common difference, okay? So yeah, AN is the nth term of your arithmetic sequence. Your first term is A1, and the common difference is D, okay? And the nth term is given by this formula right here. So for this one right here, we're going to do 3 things. Find your first term, find your common difference, write the equation, and then we're going to find the 25th term in the sequence. So our first term is 1, okay? Our common difference is, well, we're subtracting 1 each time, so it's a common difference of minus 1. And when we put this in our equation, it's going to look like this. AN is equal to 1 plus n minus 1. Right? That 1, that's your first term right there. Okay, boom, boom. And then we're going to be multiplying this part of it times the common difference of negative 1. Okay? And so if I'm looking for the 25th term, right, it's going to look like this. A 25th term is equal to the first term plus the n value minus 1 times the common difference. Okay? Remember that common difference is the last one right there. PEMDAS, we're going to do our parentheses first. So we get to 24 for that. And then our next step, right, we're multiplying next, so it's going to be 1 minus 24 after we say 24 times negative 1. Sorry, let me continue this. And then our 25th term right here, after we figure out 1 minus 24 gives you negative 23 for your 25th term. Okay, now, this problem right here drove me batty for a bit before I could actually figure it out. But it turns out that when you have a carnival that charges $2 for each game you play after you pay a $5 entry fee, you would think, oh, your first term is $5, right? But realize that your first term is not $5, right? Your 0th term is $5, right? So it's not 5 for your first one. Your first term is actually 5 plus 2 because you play 1 game. That's your first term, okay? So that was what was screwing me up, right? Your 0th term is 5, which does not factor into your formula, okay? So your first term is 7 right there. Your common difference is going to be 2. That's the game you play, right? Or each game you play. So your equation is going to look like 7 plus, an equals 7 plus n minus 1 times your common difference of 2, okay? So that's what your formula is going to look like right there. And then when I actually plug everything in here that I'm supposed to figure out how many games you can play when you have 29 bucks, right? You take that 29 and you put that in place of your the nth term, right? Okay. So then we take our first term right here, and minus 1 times your common difference. Make sure that's on there. And let's subtract that 7. Just get that right out of the way. So we get 22 equals n minus 1 times 2, and then we'll distribute. So 22 is equal to 2n minus 2. We add 2 on each side. We end up 2n equals 24. Divide by 2 on both sides. Then you get n equals 12, right? So how many games can you play? You can play 12 games for $29. Okay, I'll have that on there. Yeah. There you go, guys. Again, if you need to rewind this at all to get anything you missed, please do. At this point, we'll hand out the kind of work that you're doing today. Before you hand that out, sorry, I'd like you to glue this in your notebook if you could. So take a few minutes for that. You know how to do that. Hand out the next worksheet, which Lizette will collect at the end of class and put in the turn-in folder for period 6, just like always. And that should do it. If I get individual reports saying that people were good, those individual people will get a prize. So maybe that will motivate you to stop talking. Anyway, guys, I miss you, and I will see you on Monday.